Pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Okay, today we're going to be graphing secant and cosecant. So right now this is not any specific problem in the book, so I just want to graph your basic cosecant, y equals cosecant x. This is the simplest way that I graph them. Again, I don't plug in numbers and then go from there. So I'm just showing you the way that I do it, that I like to do it. So cosecant, what is the reciprocal of cosecant? Reciprocal of cosecant is sine. So 1 over sine is the same thing as cosecant. They're reciprocals of each other. So the way that I like to graph cosecant and secant is to graph sine and cosine. So right now let's just focus on cosecant. So cosecant is 1 over sine, same thing. So I am just going to graph y equals sine x first. I'm going to do that, okay? So by now you should be able to graph your just y equals sine x. Sine starts here at 0, it's up at 1 at 90 degrees, back at 0 at pi, down at negative 1 at 270 or 3 pi over 2, and then back at 0 at 2 pi, okay? So I'm drawing a dashed line because that's not my final answer. But that is your basic sine curve, okay? One thing that I want to point out though now, so I am looking at cosecant, which is the reciprocal. So now if I had sine x in the denominator, what number can we not have in the denominator? You cannot have a 0 in the denominator. We cannot do 1 over 0. 1 over 0 is undefined. 0 in the denominator for anything is undefined. So if you look here at 0, when you put in 0 for x, sine of 0 is 0. So that would make this denominator 1 over 0. You can't do that. Same here at pi. If you do put in 180 degrees right there for x, sine of 180 degrees is 0. That would make this denominator 0. Same here at 360. Okay? So where your denominator is 0 is undefined. And at those places you will have what's called an asymptote. It will be represented as a dashed line. So I'll tell you what, I'll just do here. I'll just do red as a dashed line. These are called asymptotes. Those are boundaries. Your graph will never cross these boundaries. And this shows that where you have 0 in the denominator. Okay? Asymptotes are created where you will end up having 0 in the denominator. Okay? Cosecant and secant will have asymptotes. This creates a discontinuous curve. Sine was continuous. It goes on and on and on. Cosecant and secant will not be a continuous curve, and you'll see that here in just a minute. So once I've done that, so since cosecant is a reciprocal, then it will be the opposite of sine. So here we'll still have this high point, but since sine looks like a hill right here in this area, cosecant will be the opposite. Sine is a hill, that way cosecant will be, I like to call it a valley. It will be the opposite. This curve is the opposite of this. This looks like this is the high point of sine and it becomes a low point of cosecant. Same here, this looks like a valley for sine, but for cosecant it will be the opposite. This point will still exist right there for cosecant, and then for cosecant it's a mountain. And these lines go toward the asymptote and get close to the asymptotes, but will never cross them. They are boundaries. This is called a discontinuous curve because I have to pick my pencil up to go to the next section. Okay, there's a break in the curve with the asymptotes. So, in my opinion, this is the best way to graph cosecant and secant. Cosecant is a reciprocal of sine. Graph your sine curve first. Create your asymptotes of where it's going to make 0 in the denominator. Then the cosecant curve will be the opposite of what's going on in the sine curve. Okay, now let's look at secant. Y equals secant x. Secant is the reciprocal of what? It's the reciprocal of cosine. So 1 over cosine is the same thing as secant. So now we have to determine where is it going, what degrees, 0, 90, 180, 360, 270, where is it going to create 0 in the denominator? Wherever 0 makes the denominator, that's where our asymptotes will be. So the first thing that I'm going to do is always graph basic cosine. So I'm just going to graph basic cosine first. So cosine starts at 1 at 0, then at 90 degrees it goes to 0, then at 180 it's down at -1, 270 it's back at 0, and at 360 it's back at 1. So I should have drawn that as a dashed curve because that's not my final answer, because that's cosine. Okay, so now where is it going to create 0 in the denominator? Well, it's at your 0 points. Here, if I put in 0, if I put in 0 for x, cosine of 0 is 1. That's not an asymptote. That would be 1 in the denominator, so that's okay. 90 degrees, here at pi over 2. If I put in 90 degrees here for x, cosine of 90 is 0. Okay, that puts 0 on the denominator. That creates an asymptote. That creates an asymptote right there at 90 degrees. At pi, if I put in 180 degrees for x, I get -1. So it's okay to have -1 in the denominator. 270, if I put in 270 for x, cosine of 270 is 0. I can't have 0 in the denominator, so that creates an asymptote there. So wherever you have zeros right here along the x-axis, that will be where your asymptotes is. At your, I call them 0 points. 0 on the x-axis. 0 on the x-axis. That will create your asymptotes. Okay, remember, cosine is a continuous curve. And so it does that both directions. It's going to do that. It's continuous. Okay. So that's cosine. My mind said cosecant. Cosine is continuous. It goes on and on. Okay, now we're graphing secant. So secant will do the opposite. Okay, like right here, there would be another asymptote here. And if you look, your asymptotes are going to be pi distance apart. 1, 2, 3, 4 tick marks apart. So if I want to draw my other asymptote, 1, 2, 3, 4, it'd be that distance apart. So here is cosine, so secant will be the opposite. Okay, so this is the high point of cosine, so this point will be the low point of secant. Since they're reciprocals, then the curve is exactly the opposite. Here, cosine is a valley, which means secant will look more like a mountain. Here, cosine is a mountain, so secant is a valley. The high point of one becomes the low point of the other, and then your graph goes toward the asymptotes but will never cross them. And then this right there is your final. That would be the final. That is your basic secant. Okay, now let's actually do one of these problems, 24D3. So y equals secant x plus 1. Well, this plus 1 shows you're going to have a translation. It's going to translate up 1. Okay, positive 1 means up 1. Translate up 1. All the meanings of the numbers are still the same as sine and cosine. So my recommendation is to always graph sine or cosine, your basic sine or cosine first. Make your changes to sine or cosine. Then draw the opposite of that, which will be your secant or cosecant. Okay, so secant. What is the reciprocal of secant? Reciprocal of secant is cosine. So basically, I am going to graph y equals cosine x plus 1. I'm going to graph that curve first. Then I will do my secant. Okay, so always start with basic cosine. I'm doing cosine because that's the reciprocal of secant. So always start with your basic cosine. Starts here, here, go down to here, here, here. You should have that like ingrained in your brain already. So that dashed line is your basic cosine. I draw my asymptotes in first. Before I make any changes, I draw my asymptotes in. The only time your asymptotes are going to move in the secant and cosecant equations is when you have a phase shift. Phase shift will shift your curve to the right or the left. Okay, shifting this up or down doesn't make my asymptotes move. Shifting this to the right or the left will make my asymptotes move. Okay, so once I draw my basic cosine in first, then I will draw my asymptotes. Okay, my asymptotes are at these 0 points. Where is it going to make 0 in the denominator? 0 in the denominator are at these points that are 0 on the x-axis. So I have an asymptote there, and I have an asymptote there, and if I want to count 4 over, 1, 2, 3, 4, there would be 1 there, 1, 2, 3, 4, and there would be 1 there. Your asymptotes are pi distance apart, which is 4 tick marks. Okay, now that I did that, I'm going to make my changes to my cosine. That's basic cosine, but I need cosine x plus 1. Plus 1 means translation up 1. So I take each one of my dots and I move them up 1. So this one is going to, it's just like last lesson. Take this dot, it goes up 1. Take this dot, it goes up 1. This one goes up 1. This one goes up 1. Okay, I'm still drawing that as a dashed line because that is not my final graph, because that's a cosine. I am trying to graph secant. Okay, now that I've done cosine x plus 1, I've done this but with the plus 1, now I'm ready to draw my secant. Okay, so this high point of cosine now becomes the low point of my cosecant. So my cosecant, or my secant, not cosecant, my secant graph will look like that. This low point of cosine now becomes the high point of secant. So that valley now gets turned into a mountain. This high point right here becomes the low point of my secant. And your graphs will always go toward your asymptotes but never cross them. The asymptotes are boundaries. So this, and after this it starts repeating itself. This and this is one period. After that it will start repeating. Then you have a this, and then you would be back like a mountain. It would just keep repeating itself. So this would be one period, and then now it's repeating itself. This again, and so forth. So this red is your final answer. And again, I recommend you label your final answers. Okay, we're looking at 24D2. Y equals 2 cosecant x plus 4, x plus pi over 4 minus 1/2. Okay. My recommendation is to graph this equation as if this was sine, because the reciprocal of cosecant is sine. So I'm going to graph this whole equation as if it was sine and make all the changes to it in its sine graph before making it into a cosecant graph. So essentially I am going to graph this. Y equals 2 sine x plus pi over 4 minus 1/2. You have to remember what each of these numbers are. This 2 out in front represents amplitude. There's an amplitude change. X plus pi over 4 represents a phase shift. Which way are we shifting? When this is a positive, you're actually shifting to the left, because this is the same thing as x minus a negative pi over 4. We want a subtraction to be there, and that a subtraction is part of the formula. So in order for this to be a positive, this is minus a negative. Negative pi over 4 means to the left. Then translate negative 1/2. We're translating the whole graph down a half. So how do we start out? You always start out with your basic sine. So sine starts here at 1. At 90 degrees it's at 0. At pi it's down at negative 1. Nope. No. Wrong. Ignore those. That was cosine. Sine starts at 0. Try to ignore these dots. I'll put little X's on those. Sine starts at 0. It's up at 1 at 90 degrees. Down at 0 at pi. Down at negative 1 at 270. And back at 0 at 360. Okay? So here is your basic sine. The next thing I usually do first is put in my asymptotes. Okay? So where are my asymptotes going to be? Where does it make my 0 denominator? At these 0 points. These 0 points will make my denominator 0, because cosecant is the same thing as 1 over sine. So at 0, sine of 0 is 0. That would be 1 over 0. I'd be 0 in the denominator. So here is my original asymptotes. I say that because we have a phase shift in this problem. And because there's a phase shift, that shifts your graphs to the right or the left, which means your asymptotes will also shift to the right or to the left. Whenever I have a shift, a phase shift, I do the phase shift in the actual graph last, but I actually move the asymptotes first. It's easier if you move the asymptotes first and then make the changes to your graph. So since I know that there's a phase shift, that my whole curve is going to shift to the left, pi over 4. Pi over 4 is 1 tick mark. then that means these asymptotes also have to shift 1 tick mark to the left. So all of these asymptotes have to shift 1 tick mark to the left. So I'm going to end up doing my final answer in green. So my new asymptotes, the asymptotes also have to shift because there's a phase shift. My asymptotes also have to shift pi over 4 to the left. That's 1 tick mark. So this asymptote here will now be here in the green. This red asymptote will shift to the left 1, which will now be there. This asymptote will shift to the left 1. Okay, so I'm going to go ahead and just label that this green, the green, will be my final answer. Okay, now I'm ready to make changes to my curve. So keep up with all your colors. So now try to ignore your asymptotes for a second and let's make changes to this curve. So the very first change I want to make is, you do it in the same order as last lesson. You want to do amplitude first. Okay, there's no period change, so we don't have to worry about period change. So then the next thing we do is amplitude. We want our amplitude to be 2. Right now our amplitude is 1. Amplitude is half of the distance. If I was to draw a center line, this axis right here is my center line, and you can see that from this axis to the high point is 1. This axis to this low point is 1. We want it to be 2 now. From my center line to my high point, I want it to be 2. So I'm going to take that, I'm going to use red for my next. So this needs to be up 1 because I want from my center line to my high point to be 2, a distance of 2. 1, 2. These 0 points don't have to change, okay? It's just that this is changing. From my center line down to my low point needs to be a distance of 2, so this goes down to -2. So this will be my new change. Those 0 points didn't change. Okay, the dashed red is now I'm at my next step. That was the amplitude change. Okay, so if you want to make this note, the red is an amplitude change. Well, it's hard to read. The next thing that I have to do, phase shift is always last. The next thing is translation. So now I need to translate down a half. So I'm going to use blue for that. So I need to take all these points on this red dash and go down 1/2. So this point now goes down to there. I'm just moving down a half. This one goes to here. This 0 point goes down a half. This goes down a half. This one goes down a half. So now I'm connecting all of my blue dots, and this does get pretty crazy with all this stuff on here. You have to keep up with it. The blue represents a translation change. I'm just going to abbreviate translation. Okay, now I'm ready to do my phase shift. I'm still just working with my sine curve. Okay, I'm ready to do my phase shift of pi over 4 to the left. So I'm taking each of these blue dots and moving them one tick mark to the left, because 1 tick mark is pi over 4 distance. Okay, so take this blue. It doesn't change its position as far as up and down. I'm just moving it to the left one. This gets moved to the left 1 tick mark. This gets moved to the left 1 tick mark. This gets moved to the left. No, that was 1 tick mark. This gets moved to the left 1 tick mark. Okay, I'm going to draw this a solid color brown. All these dashed lines are getting too confusing. Okay, so the brown represented phase shift change. We have now changed everything in our sine curve, so now we're actually ready to draw our cosecant graph. So all of these changes have been made within sine. Well, cosecant is the reciprocal, so that means the graph will look exactly the opposite. Where this is a mountain, then cosecant will look like a valley. So the high point of your sine becomes the low point of your cosecant. Okay, and then remember, it's going to get closer and closer to these asymptotes, these green asymptotes. That's my final answer. Then here, the low point of your sine becomes the high point of your cosecant. And then the pattern would repeat itself. If I want to draw it again, that is one period, and then it would repeat itself. One of the main things to be able to check your answers to see is this high point or low point centered within your asymptotes? If this is not centered within your asymptotes, something is wrong. So this high point and low point, or this low point and high point, should be centered in that asymptote, and it is. So the green, I've got it labeled, the green is your final answer, because this is cosecant. Just have to remember at the end to actually draw the cosecant or secant graph, because the goal is to not graph sine and cosine. We just use sine and cosine to help us get to the cosecant or secant. Okay, now we're going to look at 24a3. Y equals secant x minus pi over 2 minus 1. Since we're dealing with secant, what's the reciprocal of secant? Cosine. So essentially, I want to graph cosine of x minus pi over 2 minus 1. I'm going to graph all this with cosine, make all the changes in cosine, then I'll be able to get the secant graph easier. Okay, this is just my way of doing it. I think it's easier in my opinion. So we start out graphing basic cosine. Okay, cosine starts at 1, goes to 0 at 90, down to -1 at pi, back to 0, back up to 1. Okay, so this is your basic cosine. In my opinion, go ahead and draw in your asymptotes. Draw those first. Where are we're going to make our final graph green. Well, so where are our asymptotes now? They're at these 0 points. So these are the points that will make 0 on the denominator when you're doing the reciprocal. So since cosine is 0 here, if you do the reciprocal, it would be 1 over 0. So there's an asymptote there. There's an asymptote there. I would recommend drawing the other ones. They're always going to be pi distance apart, which is 4 tick marks. So there would be an asymptote there. 1, 2, 3, 4. There would be one there. They're at every multiples of pi over 2, starting out. The only time your asymptotes are going to move is when you have a phase shift. We have a phase shift in this problem. So therefore our asymptotes are going to move. Negative pi over 2, that's the same thing as saying minus a positive pi over 2. You want there to be a negative in the formula. So this means positive pi over 2. Positive means we're moving to the right, and we're moving pi over 2 distance. Pi over 2 distance on our graphs is 2 tick marks. So all of these asymptotes have to move to the right pi over 2. They're going to move 2 tick marks to the right. So this is going to move 1, 2. So that new asymptote is there. That it's going to go this way. Okay? So this new asymptote goes over 1, 2 to the right. This new asymptote, 1, 2 to the right. This one, 1, 2 to the right. And if you want to white out your old asymptotes so it's not too confusing, that's fine. Our new asymptotes are the green. So try to ignore the red and just look at the green. Now that we've moved the asymptotes, you can just ignore those for a second, and we're just now going to make changes to the graph. Okay, so let's make changes to the cosine graph. Well, there's no amplitude, there's no period change, so the next thing we do is translation. Okay, so we're going to translate down 1. So take every point, move it down 1. Take this point, move it down 1. This one, move it down 1. This one, move it down 1. This one, move it down 1. So this red is my translation change. I'm not going to label it, but the dashed red, here I'll just make it solid red. Okay, so the solid red is the translation change. So I'm not going to label it. So this red is our translation change. Now we have to do a phase shift. Okay, phase shift pi over 2. It's a positive. When there's a negative here and then no sign, that means minus a positive. Minus a positive. So that is a phase shift to the right. So we need to take all these dots and scoot them over to the right. 2 tick marks. We're moving them over to the right, pi over 2 distance. So this goes over 1, 2 right there. This one scoots over 1, 2 right there. This one scoots over 1, 2 right there. This one scoots over 1, 2. This one scoots over to the right 1, 2. Okay, so this blue curve is my taking into account the phase shift to the right. I'm not done. I made all my changes in cosine. I made all the changes to the graph in cosine, but now I've got to turn it into secant. Secant just means it's the reciprocal or the opposite of what this curve looks like. Okay? If I continue this blue curve on, it would do something like that. And this would go somewhere like that. It would keep going. So what's going to happen here, since I want the opposite, this blue is like a mountain. So this high point of cosine now becomes my low point of my secant curve. This low point of cosine becomes the high point of the secant. Same here. This becomes this. And your secant curves go toward the asymptotes but never cross it. Essentially this and this is one period, but it's now going to start repeating itself. So the green is your final answer. That would be your secant curve. Okay, we're looking at 24C5. Now they're going to give you in words what they want, and they want you to write the equation. Okay, this says, write the equation for the cosecant, where cosecant has a coefficient of 2 and the graph has a shift of negative pi over 2 and a translation of positive 2. Okay, these words right here, first off, we're doing a cosecant. So it's going to look like something like y equals cosecant, and there's going to be x in there somewhere. Coefficient of 2. When they say coefficient of 2, that means coefficient out in front. That is your amplitude. So they literally mean the coefficient out in front. So that 2 goes right there, your coefficient out in front. A shift of negative pi over 2. Okay, when they say shift, this means a phase shift. And that negative literally means to the left. Okay, that means you're shifting. Negative means to the left because negative is on the graph is left. That means you're shifting to the left, pi over 2. So, and then translation, that's written at the very last of the equation. Positive 2 means you're translating up. A positive means up. So to write this in equation to the left, well, cosecant, your base shifts are written in parentheses. The formula is a negative, but we are shifting to the left, pi over 2. So the formula is a negative sign here, and we're shifting to the left. Then we have a translation out here of a positive 2. Okay, we need to clean this up. So when you have minus and negative, it then becomes a positive. So y equals 2 cosecant x plus pi over 2, and then plus 2. And this is what the equations look like that we have been graphing. Because when there's a positive sign here, that means to the left. You're shifting to the left, because that would be minus and negative. And then this positive means translating up. So all you're doing on these is taking those words and then putting them into the equation of what they're wanting.